All right, so we are starting our new unit, and that new unit is logic. And we're going to start off with something I consider the foundation of pursuing logic, deductive reasoning and inductive reasoning. And we're going to be exploring both over the next couple of days. And let me acknowledge something, and I know this is true. Logic has a real different flavor than ethics. And in the past, I've had some people say, I'm not really a logical person. It's really not my thing, and the switch goes off. And I've had the reverse happen with ethics. People say, I'm more, I'm a math. They call themselves, I'm a math guy, or I'm a left brain person or a right brain person. Let me address two things in the hopes that all of us stay in the mix throughout all of philosophy. And this idea of a left brain and a right brain, it's more of a metaphor than it is empirical fact. Not to say that different parts of our brain aren't responsible for different things. Obviously, even if you have the most rudimentary brain education, you know this to be true. And people who call themselves, I'm left-brained, I'm logical, I'm sequential, I'm rational, and the right-brained, I'm subjective, I look at the whole, even this very simplistic notion of right brain, creative, left brain, analytical. Okay. Listen, we use our entire brain. All of us are capable of any type of philosophical thought. Now, one might be more interesting to you, one might, come easier to you, but we are all capable of it. And while we're on the subject of things that are on myth, this is a straight up myth. If people say we only use 10% of our brain, that is not true. In fact, the quote I chose is from the Johns Hopkins School of Medicine, maybe the best school of medicine in the country, where they say the 10% myth is so wrong it's almost laughable. So please be open to learning, even if you consider yourself, I'm quintessentially a right brain person, okay? Stay in the mix, because I'm of the belief as an adult, all of these philosophical skills will come into play as you go through life. I do believe that in my heart of hearts. So what's logic? On the simplest of level. Now, if you were thinking this, that's a lot more fun than this. I get that. But it seems like mathematics or economics or this kind of thing. This is more the realm of logic. So the egghead technical definition is logic is a science that deals with the principles and criteria of validity, of inference and demonstration. It's the science of the formal principles of reasoning. It's taking thought and it's plotting, it's charting, it's pattern seeking. This is what logic is. And I don't want to scare anybody away with this. If I were to introduce the unit with this, I think that switch would go off, as I've already mentioned. And charts like this, inductive reasoning versus deductive reasoning. Again, switches go off and they see these. But let me give you the quick and basic version of this. So inductive reasoning, you start with an observation, which turns into a pattern, which goes to hypothesis, and then it goes to theory. So I will share with you a real-life application. Last year, I was observing any student that was involved with the theater, grades were going down. They were exhausted. They were falling asleep in class. Students who were normally very conscientious students weren't doing what they used to do. So my hypothesis was that the theater students might be staying too late or being pushed too hard, and it created a theory. Whereas deductive reasoning, you go the other way around. Recently, this happened to me recently, I was getting my lawnmower in order for the springtime, and it didn't start. I could not get my lawnmower to start, and I had a theory. My theory was the oil was bad. So I changed the oil. That wasn't it. And I went down the line and I checked everything till eventually I got it to work. Now, if I was initially correct, I changed the oil, it works. I've confirmed this. Now, you're going to see it more like this. Okay, that's taken directly from my whiteboard. I know I'm not much of an artist. So deductive is this narrowing down to one outcome, where inductive, it goes outward. And people always make fun of me when I do this, because every time I say deductive, I make the funnel shape with my hand, and inductive, I take it the other way around. So I do acknowledge my Italian heritage. And I do acknowledge I talk with my hands. I can't stop. Please don't make fun of me. So here's evidence to the point right here. So anyway, examples of deductive and inductive reasoning processes. Again, deductive, you get a lot of this, multiple choice. We even teach you this, process of elimination, POE. Okay, A no, it's definitely not A. I'm going to cross it out. B, it could be. I'm going to circle it. No, it's not C. It could be D. 50% is better than 33% or 25%. Basic test-taking skills, repairing things, as I've already mentioned, my lawnmower, algebra and geometry. You have to deduce down to one answer. And if you ever hear the expression, I got to narrow things down. Okay, if you ever say those words, you're using deductive reasoning. Whereas inductive, you see a lot of it in social sciences and documentary films. A documentary film will focus on one family, but that family is representative of a larger issue in society, case studies. And if you ever hear the expression, hey, I got to put things into a broader construct, or how does this fit in, or from this, what can I extrapolate from this one thing? Different ways of thinking. So we're going to start with some fun. At least I think it's fun, and most of my students think it's fun. If you didn't think it's fun, I'm sorry. But we started with the game Quarto, and we engaged in a double elimination tournament. In Quarto, as you can see, there are 16 circles, and you have to get 4 in a row, excuse me. And both sides get 8 pieces, and you're going to notice we have dark and we have light. We have circle, and we have square. We have solid, and we have hollow, and we have tall, and we have short. So you have to figure out how to arrange these pieces to get 4 in a row, whether it be by color, by shape, hollow or solid, or tall and short. Easier said than done. And some people did better than others in the tournament. And here are some past winners to prove it with their respective prizes, and we can see the game going on. You know, both of these gentlemen, they are focusing in on trying to say, well, you know what, I have this many pieces, there are this many pieces on the board. I need to deduce the best play in order to have a positive outcome, winning the game. And you can see these two engaged in this practice, and with every move you have to readjust your deductive reasoning. So one individual plays a piece that changes your choice. You have to look at this, and that's the deductive reasoning process, and Quarto is a wonderful way to show that. So I hope you enjoyed the tournament, and from Quarto, hopefully you took from this game, a board game which is light and fluffy, to the heavy stuff. And what we can take from Quarto is this idea that formal logic is more like the sciences than is any other part of philosophy. It aims at a systematic account of a body of phenomena on which there is fairly widespread agreement, and in order to do so, it uses formal methods of representation and formal techniques. Formal logic is formal in that it seeks to give a systematic account of the validity of an individual argument only insofar as they exemplify certain patterns of argument. Patterns or forms of argument are the main object of study. It is this feature of logic that allows us to establish some results in and about logic with the same exactness as one encounters in mathematics. So in Quarto, it's literal. This piece is the most logical piece to play. But when you take it into arguments, when you take it into policy, when you take it into these areas, you're using the same thinking process. And here are some other reasons to start logic, or to study logic as we start off our unit. Logic is therapeutic. One learns logic in order to become better able to recognize and to construct good arguments. In philosophy or any other discipline, you see argument in a very pattern-oriented way, or a mathematical sort of way, so you can formulate good arguments. Formal logic is an indispensable item in the contemporary philosopher's toolkit. And that's what I hope you all become, contemporary philosophers. And once you have this tool, you're formidable. You have this tool in your toolbox for the rest of your life. Now, the goal of establishing logical arguments is eventually to achieve reductio ad absurdum, or reducing your opponent's argument to absurdity. And if you can take an argument and chart it out and think it out and find the patterns, whereas your opponent is going kind of willy-nilly, not thinking it through, you will make them appear absurd. Even in the game, I heard some people chuckle because people who were struggling with the game played an illogical move, and you chuckled. You go, oh my goodness, that's an absurd move. That's the connection between Quarto and logic. Now, deductive reasoning is a means of taking all possibilities and using a process to narrow it down to an outcome of one. So, to wrap up, in your journals, please write the following. What thinking processes were required in order to be successful in Quarto? What are the differences between inductive and deductive reasoning? And provide examples from real life of when deductive reasoning is used. So, we're going to pursue inductive reasoning after that, but in my opinion, deductive reasoning, inductive reasoning, these are the foundations of pursuing logic, which I think is a very worthwhile field of study and something that you will use throughout your life, whatever you do for a living. It's essential, it's important, it's valuable. So, thank you for watching.